Excellent. All right, so all our tutorials are on the tutorial tab. And we will start with our overview of our JupyterHub. So let's start off talking a little bit about what is a JupyterHub, why are we using it, and also why are people using a lot more cloud computing in this new era of big Earth data. With this introduction, we want you to get an idea of the, what it means to be working in a cloud environment and why we do it. Learn some of the general technical tools that we use when we're working in a cloud environment. And then the next part is give you a really brief walkthrough to our JupyterHub and how to use it. We will be available during the work times to jump into breakout rooms and debug any issues that you have during your work times. Also, you can use the help desk channel. All right, so big data. This is just NASA's Earth fleet. NOAA also has an Earth fleet. The European Union has Earth satellites. India has, Earth satellites. China, this is just NASA's Earth fleet, and this is a lot of data. So just huge volumes of data. And that's super exciting. We are going into an era where we're observing the Earth in ways we have not before, new types of data. You just listened to 2 lectures talking about the new kinds of data and insights that we can get from the PACE satellites, but there's all these other satellites coming on board, and they also are giving us new data and insights about the Earth. But it's a lot of data. And, back in the day, back when I was a young graduate student, we downloaded data, and we always worked, we'd download the data we wanted to work on, and then we worked from our computer, or, if it was something really big, we'd download the data to a cluster, high performance cluster. Well, now the data is just way too big to be doing that. Here's a graph, and it's only going out to 2029. It continues to go up, and these are, how it's rapidly growing. And this, again, is just NASA's data. There's all sorts of other data streams out there also that are growing it. But just looking at, NASA's archive, this is petabytes, and you can see it's getting really, really massive. This is way too big to be using these traditional download the data to my computer and work from it from there. So Earth science has, for a number of years, decades, been moving to develop the tools and the infrastructure to have data in the cloud, to be able to work with data that is stored offsite of your computer, and you don't have to download that data to work with it. So we're moving towards this cloud architecture that involves a few key components. One of those is something called cloud native data, and it's data that you can stream. So think about when you watch a movie. Now, you don't have to download the whole movie to your computer. You're able to stream it. And not just you are able to stream it, but, hundreds of thousands of people can stream it at the same time. That is this cloud native data. It's a new infrastructure of how we can interact with data. Secondly, cloud computing next to the big data. There is a cost to moving data between data servers. So the data we'll be using is in AWS US West 2. And moving that data out of that region into another region or into a Google bucket or onto your computer, there's a cost associated with that. You don't pay that cost, but NASA does. And there are situations where you also would be paying the cost for moving data from a cloud bucket to a cloud computer. But if you're in the same region as that data and with the same cloud provider, you're not paying that. There's no cost, no movement cost, but also you're optimizing the speed of your calculations. So we ideally would like to have our cloud computer next to our data up in the cloud. Our JupyterHub we're using is also on AWS US West 2. So we are not incurring NASA a cost by, connecting to their data. In addition to that, we also need lots of tools, lots of software tools, and to use this cloud data, use this big data very efficiently. And we are going to be using a set of tools that are called the Pangeo ecosystem of tools. This has been developed by the big data earth science community for many years, and it's been like a game changer for earth science research. And then lastly is really having the community embrace open science collaboration. These tools that I'm talking about, the community was able to develop those because they worked openly and collaboratively. They share their code, they share how to do things, and they work together on hard problems, just like we're doing during this Hack Week. All right, so cloud computing architecture. I kind of hinted at this. This just shows it graphically. So we have our basically our data servers, and then we have kind of these whole things here, which is our virtual computing. And then us as users, we interact with this from our computers via a browser. That's what we're going to be doing with our JupyterHub. Okay, cloud native data. I mentioned that it's optimized for streaming rather than downloading. Well, like, what does that mean, and why would we care about that? So as I kind of alluded to, one is that, you don't want to be downloading petabytes of data. I mean, that would take forever, and you'd have to have these big, massive, very expensive data servers, and it's already up there in a server. Why would you like duplicate it? So that's one thing. But another really key thing about cloud native data is that it's what's called chunked. And we have developed, this is the community, the earth science community has developed, this is the Pangeo ecosystem of tools, made it really easy to work on that data with a whole lot of parallel processes. I kind of think of this visually like a whole bunch of piranhas. So we have some problem, and this data is way too big. If we tried to like grab it all and do, let's say we're taking means and variances or something like that, we couldn't even load it into memory. And also, if we just tried to do it with one computer doing that would be really slow. Whereas if we do it with a whole bunch of little processes and they just do it on these little chunks, we can kind of attack it with these piranhas and do a problem much more quickly and first off, we can do problems we couldn't do otherwise. We can work with larger than memory data, and we can also work with larger than memory data with fairly small virtual machines. So that's, as I said, this Pangeo ecosystem of tools. That's what we're going to be using. You're going to be learning, and you learning these tools is a big objective of this Hack Week because it will change your trajectory as a earth scientist to learn and be familiar with these tools. They are Python tools. For those of you who are R users, these tools allow you to get the data, munge the data, and then store the process intermediate data in a format that then you can read into your R pipelines. But I would say for processing this big data and getting it into the intermediary formats, you're going to want to learn some Python. Fortunately, now with AI chatbots, that is so much easier than it used to be. Okay, here we go. And, as I said, the open science collaboration has also transformed the field. And if you have not been exposed to that, I encourage you to, do some Googling. NASA has been very heavily involved in the earth science, open science movement, and very instrumental in helping the field move forward. We are using a JupyterHub that is developed and maintained by a group called 2i2c, and they maintain many hundreds of these JupyterHubs across both agencies and also a lot of different universities, community colleges. And so I want to give a shout out to them. Okay, so now what we're going to do is we're just going to jump right in and jump into our JupyterHub and take it for a little whirl, little spin, and make sure that you are able to get on. So if you need to watch what I'm doing later, you can go to this video. The slides, just so you know, see here. If you go onto our Slack and you go into Hackweek, you're going to see links. So if you click links, you're going to see our Google Drive. And then you'll see presentations, and you go in there, you'll see all these presentations. Okay. So let's go back here. And we're going to go to this URL. I will, let's see, let's copy it for you. Copy link address. Here we go. And I'm going to log out, so it'll be a little closer to what you see. Let's go here. Okay. Oh, nope, that is not what I wanted to pass in there. Let's get this right here. This is what I wanted. Here. That's where I want you to go. Okay, great. Get out of that. Okay. So when you go to this, if you have accepted our invite to the FishPace the FishPace GitHub organization, when you click here, you should see this. It may ask you to log into GitHub. So go ahead and log in if you need to. If you get something that says I think it's 403, you don't have access, then you need to do one of two things. First, go on to if you go onto the FishPace org, so it's github.com FishPace, and usually it's like up here. If you look here, you might see a notification inviting you, and then you can accept and join our org. If you don't see that and you still can't get on, then you'll need to DM me a message in the Slack with your GitHub username, and I can add you. All right. For the rest of you, you should see something that looks like this. You won't see the GPU. We do have that available for the projects that need GPU, or you can also use Colab, that's a pretty good way to get GPU. But we do have some GPU available. Okay. Get here. All right. So what's going on here? So what I'm about to do is I'm about to start up a virtual machine, a virtual computer that is all set up with a whole bunch of tools. And this resource allocation is the size of the machine I am getting. You have, get up to a pretty large one. However, almost everything we do, you can run with 2 gigabytes of RAM. So just use the small one, saves us money. We'll note in tutorials if you need to grab something bigger. The next one up here is the image. And what's going on here is you're grabbing a environment that's set up with all the different packages. We're just going to use the default. However, I want to note here that we do have a pace image with some extra tools if you're doing a project and you need to be able to, I think it's processing, it's either level 1 to level 2 or level 2 to level 3. Can't remember. Right. Okay. But this is a fairly, fleshed out environment. So we're going to go ahead and start. And now what's happening is it is starting up my computer or this virtual machine for me. And there we go. Sometimes what you'll see is it says it's downloading the image and it may take longer. And if that happens, just be patient and, let it start up. Okay. Okay. So when you start it up, you should see something that looks kind of like this. So this is what's called your launcher page, where you can start various things. And you're going to be going to this page or this actual tab here a lot. And so let me show you how you get this. If I close it, the way I get it is I click this blue button. You're going to be clicking that blue button a lot. There. If I can navigate to different folders here, let's see, here's tutorials here. Then you can see the blue button still up there. I can click that. The only time that blue button would disappear is if you're clicked on one of these other ones here. This one here is a common one. This is how we interact with Git. You'll learn about this tomorrow. And now you'll see the blue button disappears. So you'd have to click this folder up here and the blue button comes back. Okay, so the next key bit of navigation after the launcher you need to know about is your home directory, being able to move around. You can click on this when there's nothing here. And you'll see folders. You won't see this many. I have a bunch of stuff in here. You should see probably R, shared, and shared public. Let's check out shared public. So shared public is our shared drive where you can put data that you need to share with your whole team. Make sure to give it a name that will recognize, like give it your project name. So this, like Mind the Gap, was a project team. And then you click there and you see this team was sharing some data with each other. Looks like some a czar and some files for the Arabian Sea. So that way, everyone doesn't have to load the data sets that your team needs to share with each other. You don't have to have that in everyone's home directory. You can put it in the shared public. Okay, so now that we're here, let's look at, say, how I'm going to create a folder. And I'm just going to call this delete because I want to remember to delete this. So now I've created a folder. And I can go ahead and start a Jupyter Lab notebook, or not a Jupyter Lab notebook, a Jupyter notebook. So here we go. So let's check out Jupyter Notebooks a bit, because we are going to be using these quite a lot. And so we want you to know how to navigate around a Jupyter Notebook. So from here, you can type code and run it. So let's say, so if you look here, it says code, and then I can do something like, whoops, 1 + 1. So that's some code. And then I can run it by either I can do that to run it, it's running, or what I can do is the shortcut is to hold down the shift key and return. So shift return will also run it. You can delete it over here. You can add new bits like that, and run more. Import, let's say X-ray is something we'll be using a lot. Import X-ray as XR. XR means it's a shortcut for how we'll, instead of having to write out X-ray all the time, we can reference this package as XR. And now I can run that, and it's there. All the packages we'll be using in the tutorials are available. This is a very full-fledged environment. You shouldn't have to install anything, fingers crossed. Okay, so a few other than that, let's see, is there anything else I need to show you about notebooks? Yeah, if you haven't used these before, one other thing to know is you can go here and do markdown. So I can say, hello, this is some markdown, and here is what we are doing. And now I can do shift return, and there, so it includes some markdown. Okay. I don't know why it's doubling up there. It does that sometimes. Get why. Okay. Let's see. So up here are some other things that you'll be using periodically. So first off, right here, the kernel, you'll find out sometimes as you're working over this week that you may run out of memory. Do you see down here how you can see the memory here? And it's not very big. I can watch how big it is here. And if I start running out of memory, you can shut down the kernels. It will get rid of the variables that you've been running in your notebook. So you will have to rerun that, but this is how you would clear up your memory. So shut down all. And you didn't, yeah, you can see it dropped down a little bit here. Okay. So you're going to be having to use, shutting down kernels during this week, I assure you. All right. The other thing that I want to show you how to do is show you how to get to RStudio for those of you who are working in R. So if you're here, you can click this, and it's going to open up a new window with RStudio. There we go. All right, we go back to my home. So hopefully this this should look familiar for our users who use RStudio. It's just like on your desktop. A nice feature of this is that your home directory is the same one that you see from Jupyter Lab. So if you have Python people in your team and R people, you can both be working and be saving files to the same folders in the home directory and collaborating nicely that way. Or if you have a workflow that does part of it in Python and part of it in R, you can do the Python in JupyterLab if you want, and do the R in RStudio. However, just point out here that there is an R kernel here. So for you, this is not very common for, in my experience, for R users to be running R code in JupyterLab, but you can definitely do that if you want. So tidy verse, this should work. Yeah. So this is R code, it's not Python code. You cannot combine both Python and R code in a Jupyter notebook, however. Pick one or the other. All right. Okay, last thing to show you is how to shut down your hub or switch to a different size virtual machine if you need it. So you go into File, Hub Control Panel, Stop My Server. When you do this, you're not going to lose stuff that you have. Even if you haven't saved the file, it will cache it. So you're not losing things. You don't have to freak out about doing what I just did. Now you can start back up, and I could pick something larger. So if, say, I'm doing a visualization, I keep running out of memory, I can pick something larger and then start it up. So I didn't pick something larger, but it would work the same way. I could have. One last bit that I want to show you is this little tab here. So tomorrow I am going to show you how to work with Git and GitHub, but some of you already know how. And if you want to get just, hey, I just want to get started. I know what to do, Eli. Let me quickly walk you through how you will work with Git in this. So number one, you're going to go to our website. So if you're new to Git, just gloss over this part. You don't need to worry about this. This is people who already are familiar with it and just want to get started. So you're going to go to the setting up Git here, and you'll see this code down here. You're going to have to run this in a terminal. So you're going to do that. And how do you get a terminal from the launcher? You're going to click terminal here, and you'll get a terminal. Okay. So you got to run that code there that's on the website so it knows who you are. Then the next thing that you'll do is you can clone from here if you're familiar working in the terminal, that's fine. But you can also use this little GUI. I usually use this GUI, even though I can also work from the terminal. And you clone, and you'll clone it. Okay. Last thing, for those of you who already know Git, the way that you authenticate on this is a little different. This is covered in this thing about Git. It talks about something called GitHub Scoped Creates. So read about that and about how to authenticate on a JupyterHub. So it's all in this right here. All right. Oops, come back here, come back here, okay. So now what we're going to do is we are going to jump in and we are going to start learning how to get